girls. Welcome to lesson 9-4, which is on conics, graphing conics on the graphing calculator, and graphing rotated conics on the graphing calculator, and solving conic systems. First thing we're going to do is to figure out how to graph a conic section on your calculator. We need to solve it for y. In other words, we need to take these equations and put them in function form. So we're going to do that by solving for y. I'm going to start here by subtracting 12x squared from both sides. That gives me 6y squared is equal to 48 minus 12x squared. I'm going to divide each term by 6. So I'm going to get y squared is equal to, let's write that as, it doesn't really matter, but let's write that as 8 minus 2x squared. Now I'm simply going to take the square root of both sides. So y is equal to plus 4 minus radical 8 minus 2x squared. We are now on our graphing calculator is going to punch both of those functions into y1 and y2. In other words, in y1, we're going to type in radical 8 minus 2x squared. And in y2, we're going to type in negative radical 8 minus 2x squared. And don't forget to make sure that we type in the negative sign and not the minus sign when you do that. So go ahead and do that and punch it into the calc, and I'm hoping you get a picture that looks something like that. That is an ellipse, and it's not. Let's try another one. Looking at this one, I want to solve this one for y. Again, looking here, this looks like it's going to be an ellipse. I am going to guess that it's going to be zot, but let's see what happens. Maybe it's verb. So, first thing I'm going to do is I'm going to subtract this term from both sides. So I get 9 times the quantity y minus 4 squared is equal to 72 minus the quantity x minus 1 squared. I'm now going to divide both sides by 9. Whoop. 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 And here you can make a choice. You can simp things, but let's make our life simple, and let's not simp things. So let's just divide the whole puppy by 9. When I do that, I now get y minus 4 squared is equal to 72 minus quantity x minus 1 squared all over 9. I'm now going to take the square root of both sides. So y minus 4 is equal to plus or minus radical 72 minus x minus 1 quantity squared, that whole thing divided by 9. Then I'm going to simply just add 4 to both sides. So what I'm going to type into the calculator is this. And you need to be careful when you do that. I'm going to type in y1, y equals, let's start with the plus 1. So plus, in parentheses, 72 minus quantity x minus 1 squared, close my parentheses, still in the radical, divide that by 9, and then outside the radical I add 4. In y2, I'm going to type in the exact same thing, but this time I'm going to take the negative of my radical, so the same exact radical, and I still have to add 4 to that when I'm all done. So go ahead and type that into the calc. You can pause this if you want, but you should get a picture that looks like that. It is a zot ellipse. Why don't you try solving that one for y yourself? You may need to complete the square. So to solve this for y, I'm going to start by moving the 5 to the other side, moving the x squared to the other side. So I'm going to get y squared plus 6y. I'm just going to add my blank right there because I know I'm going to have to complete that square, is equal to negative 5 plus blank minus x squared. Well, half of 6 is 3. I'm going to square that 3 and get 9. I'm going to add 9 to both sides. So now it looks like I have y squared plus 6y plus 9 is equal to 4 minus x squared. This, of course, is y plus 3 quantity squared is equal to 4 minus x squared. Take the square root of both sides. I get y plus 3 is equal to plus or minus 4 minus x squared. Now I'm going to simply just subtract 3. So y equals radical 4 minus x squared minus 3, or equals radical 4 minus x squared minus 3 outside the radical. Go ahead and punch both of those into your calc, and you should get a picture that looks something like that. It's a circle. And I actually did that in a zoomed 5, which is the zoomed square, so you can see that it is a circle and not on the ellipse. Okay, let's talk about conics in general form. Again, not in the HK form, which your book is called standard form. Typically, you see an ax squared, a cy squared, a dx, an ey, and an f. If you see an xy term, that means that the conic is a rotated conic and it's not horizontal or it's slanted. Interesting. So when the b is an actual, when we have the b term, the xy term, it is a much more complicated conic. Okay? I am hoping that you can look at those conics right now without a b term, without the xy term, and tell me what each of those conics are, hopefully just by looking at the equation in general form without having to put them in HK form. We will go over this in class, but hopefully you can look at these right now and figure out what they are. Go ahead and give it a go. Okay, the first one is actually on ellipse and it's xant, and you can tell that by looking at the a and the c terms and seeing that they have different numbers, but they're both positive. We can look at the second one, that's a hyperbola, and it's vertical, and we know that because it has a positive x squared term and a negative y squared term. We look at the third one, we know that it is a circle, because the a term and the c term, the x squared and the y squared terms, are both positive and they're both the same number. And the last one is a parabola, and we know that because it's a vertical parabola because the x is squared. And if I move that to the other side, it would now be a negative x squared, so it's a parabola going down. When you look at a conic with a b term, that's a slanted conic, the way you can tell by looking at the equation in general form what type of conic it is using what we call the discriminant. If b squared minus 4ac is equal to 0, we have a parabola. If b squared minus 4ac is less than 0, we have an ellipse or a circle. And if b squared minus 4ac is greater than 0, we have a hyperbola. Let's graph this rotated conic on the calculator. First thing we're going to do actually is just figure out what type of conic that is. And I'm going to do that by doing the b squared minus 4ac. So looking at this right now, b is negative 1. So negative 1 squared is negative 1 squared minus 4 times a, which is 1, times c, which was 3. This now becomes 1 minus 12, which equals negative 11, which now we know that this is on ellipse because it is negative. So I know that this is on ellipse because the discriminant was negative. Right now I'm just going to erase that work so I have more room to do actually come up with my graph. So first thing we're going to do is we are going to solve this in terms for y. We're going to do that by writing this in what we call quadratic form. Okay, so I'm going to set these three terms, and I'm going to take my y squared terms first. So I'm going to rewrite this as 3y squared. I'm going to take my y terms, which in this case I only have one. That's minus xy. And I'm going to take my non-y terms, put them at the end, so I have plus x squared minus 5. If you think about this now, this is a quadratic equation in terms of y, where y is equal to 3 times y squared minus x times y plus x squared minus 5. In other words, a is equal to 3, b is equal to negative x, and c is equal to x squared minus 5. I'm now going to use those terms to write this with the quadratic formula. So, y equals negative b plus or minus square root of b squared minus 4ac all over 2a. So, b was negative x, so this is going to become x plus or minus the square root of b squared, which is negative x squared, minus 4 times a, which was 3, times c, which was x squared minus 5, all over 2a, which is 2 times 3, which is 6. Do not worry about simplifying this too much. That just makes your life harder. So in our calculator, we are going to type in y1 is equal to x plus radical x squared minus 12 times x squared minus 5. And now be careful here, in your calculator, you actually need to put parentheses around that in the front, parentheses around that at the end of the radical. Close my parentheses right there too. And we're going to divide that by 6. In y2, we're going to write parentheses x minus radical x squared minus 12 times x squared minus 5, close parentheses, close radical, close parentheses, divided by 6. And if you punch that into the calc, you should get something that looks something like that. And you can see it is an ellipse that's ever so slanty going up. And that's actually regular in the regular Zoom 6 for standard viewing window. Okay, here's a second one. Why don't you guys try that one on your own? You're going to solve that for y. Okay, if you solve this for y, you're going to put this in quadratic form. When we do that, we get, okay, you're going to first write everything out in order here. Okay, starting with my highest y term, which is y squared, plus 4xy minus 4y, plus 2x squared, plus 3x minus 20. And then looking here, my a term is 5y squared, so a is 5. If I factor the y's out of here, okay, I get my b term is 4x minus 4 times y, so b is 4x minus 4, and my leftover terms, my non-y terms, these are all my c terms right here. So c is 2x squared plus 3x minus 20. You then use the quadratic formula to solve that for y. You're going to get 2 answers for y. If you plug them both into the calculator, you're going to get an ellipse that looks something like that. And no, I didn't graph it. Sorry. Okay, lastly, we're going to solve some systems with conics. Again, we'll talk about this in class, but when you solve a conic system, you could get up to, you could have either 0 answers, 1 answer, 2 answers, 3 answers, or 4 answers. I also, too, I think it's a good idea to make a kind of a rough sketch, if you can, without doing too much work if you want to figure out what you might have. Because remember, when you solve a system, you can do it by graphing. You can use a calculator and do it by graphing. Okay? You can solve the system with elimination, or you can solve this with substitution. Rough sketch, you see, without doing too much work, do we see my first equation? My first equation, we'll call this in red here. That looks like a circle to me with a radius of 3 centered at the origin. My second equation in blue looks to me like a sideways parabola. It's a Zant parabola with a vertex somewhere off to the left. Looking at, I'm going to guess something like this. And if I'm wrong, don't worry about it, but let's see what happens. There might be up to 3 answers here. So to solve this, I think I'm going to do this actually by substitution. I already have solved right here. Y squared is equal to x minus 3. So I'm going to take this x minus 3 and plug it in right here. So I'm going to have x squared plus x minus 3, which was y squared, equal 9. Well, let's solve this for x. This is a quadratic equation. Subtract 9 from both sides. So now we have x squared plus x minus 12 is equal to 0. That's factor. I get x plus 4, x minus 3. Therefore, x equals 3 or x equals 4. Let's go back up to our original problems. It would probably be simplest to plug both of these answers into the second equation. When I do that, when x is 3, 3 minus 3, of course, is 0. Y squared is 0, so y must be 0. And sure enough, that's that point right there. If x is 4, let me switch colors. If x is quattro, I get 4 minus 3. Y squared is equal to 1, which means y is plus or minus 1. So I have actually two ordered pairs, 4 comma 1 or 4 comma negative 1 for the second answer for x. And those are those 2 points here and here. So my answers are 3, 0, 4, 1, and 4, negative 1. Okay, to solve this second one, I'm going to maybe make a rough sketch without spending too much time solving this graphically. But do we agree the first one looks like an ellipse that is going to be I'm not quite sure where it is. I don't know. Let's probably say maybe here. I'm just guessing. My second one's a circle centered. I don't know. I can't tell without completing those squares right now. But you know, it's a circle. I don't know. I might have 2 answers. I might have no answers. I might have 1 answer. I might have four answers. I really don't know. I can't tell just by looking at this right now. So let's go ahead and solve it algebraically. Let's do this one as opposed to doing it by substitution. Let's do this one by elimination. And I'm going to get rid of my x squareds by multiplying the second equation by negative 4. If I do that, I get negative 4x squared minus 5, oh, sorry, I'm ahead of myself, minus 4y squared plus, don't tell me 27 times 4, 54, 108 is equal to 0. I'm going to add these two equations right the way they are. 4x squared and negative 4x squared is 0x squared. 9y squared minus 4y squared is 5y squared. Minus 36y plus 108 is equal to 0. Okay, let's solve that for y. Let's try to factor it. I'm looking for something that combines with y and 108 and 36. I can't think of anything. So, hey, I got a backup plan. Let's use the handy-dandy quadratic formula. And I'm going to get negative b, which is 36, plus or minus the square root of b squared, which is 36 squared, minus 4 times 5 times 108, all over 2 times 5. I'm just looking right now to simplify my equation. I'm going to get 36 plus or minus 36 squared minus 20 times 108. You know what? That's actually a negative number. All over 10. And I'm done. Y has only imaginary roots. Therefore, there is no solution. Okay, why don't you try this last one on your own? I'm just looking here. I see that it looks like we have a line, and it looks like we have an ellipse. This could have up to 0, 1, or 2 answers. I would probably, if I were you, solve this by substitution. solve for either x, or we probably even easier solve this for y, and let y equal 2 minus x, and see what happens. Okay, if you do all your work, you should get 2 answers. Your answers were 0, 2, and 4/3, 2/3. That is it, and we'll see you soon.